Jumpstart Pro Android is an implementation of the Hotwire Native Android library. So by default, everything happens through regular typical HTTP communication, and Hotwire Native will naturally show the screens, hide them, etc., depending upon the navigation of the user. However, there are instances sometimes when you need to communicate with a remote endpoint. And to do that, we use a tool called Retrofit. Retrofit is an HTTP library that allows us to easily communicate with various different API endpoints. Under the hood, Retrofit is powered by OkHttp and HTTP implementation that is highly configurable. Inside of the application, we use something called the API service. The API service is how we communicate with the Rails API that we have built on the server itself. So this is actually an API endpoint that returns JSON and so forth. You might add additional API endpoints in here if you're communicating or need to communicate from the native context with the remote server. This is set up and managed with Retrofit, and this is set up inside of the dependency injection inside the HTTP module. So the library is already installed. That's inside of the libs.versions.toml and inside of the build.gradle file that we've already covered in another video. Here we have the HTTP module, and down at the bottom we provide the Retrofit implementation. Inside of here we provide the base URL that Retrofit's going to use as the base URL. This is provided using the named annotation base URL, again provided by dependency injection. So please see the dependency injection video for more information on that. We have the JSON converter factory that helps us convert JSON and so forth to and from the regular plain old Kotlin objects and serialize deserialization. Then we have the call adapter factory, which is the network response call adapter factory. And what this does is gives us this nice response type. So when we call sign out or add notification token, typically you'd get back either your value you'd want, which could be a result like a successful result or a API result. And here we don't get anything back other than just, hey, a HTTP status code such as 200, or if there's an error like a 500 from the server. And network response is a library that allows us to have some very simple implementation. So let's just go take a look at sign out real fast. And sign out, we have right here, we get back the response, and the response is a network response. And here we can say when we return so we can turn this to an API result. This is an extension function here. And what we do is we check the network response. If it's a success, then we have an API result class. Let's take a look at that. That just has two results. When you call an API, there's two things that happen. You either have a successful result or you don't. It's most likely an error, something bad happened. So in this instance, however, HTTP communications can have all different types of results. You can have 404s, you have 300s, you have 200s, you have 500s. The network response library helps us determine which one of these is, and then we can build our API result off of that. So if it's a success, we return an API result.success, and we return it back with its actual body that we have, which is on success here. It's a method to transform the success into the object that you want. Then we have a network response server error. So if we get a server error that comes back, which we can see here, is a server error, and it's a non-200 response. If we get back a non-200 response, cool, we're going to turn that into what's known as the HTTP API HTTP exception, where we get the code, the headers, response body, and perhaps a message, and perhaps they throw a bullet itself. And then we return an error. If we get a network error, we do the very similar thing and create the error here. If we get an unknown error, something we completely weren't expecting, then we return a API error as an unknown error. Now this is really useful because back inside of our code, we can easily return back an API result. So whoever is calling this user repository to sign out is going to get back a result, and that's going to be an API result. So if we look at the API result, the API result is a success or an error. And so inside of here, we can easily determine what to do. So we're going to handle the sign out state. If it was a success, we know what to do. Something good happened. Let's follow that happy path. If an error happens, cool, let's get the error message off of that and then determine what to do. In this case, we're going to show a dialog, which is a native dialog to the user with the error message in it, at which time the user could figure out what to do or report it to support or something of that nature. So this is how we communicate with the backend. Now, this again is set up inside of the HTTP module. And the HTTP module with that network response adapter gives us that nice error handling for server errors, unknown errors, network errors, etc. Then we can map it into our API result, which is an object that we own. Now, underneath the hood, though, we do need to be able to communicate with the backend in an authenticated manner. And we also need to be able to make sure that we can accept JSON, and we need to make sure that we are setting up the proper user agent. So when the request gets to the server, it knows it's coming from a Hotwire-based application. OkHttp is our HTTP client that sits underneath the hood of Retrofit. It's what powers Retrofit down below. And we need to configure OkHttp to do a few things for us. And that's what we have here. We have a logging interceptor, and we set the logging level to be either none in production, or if it's in debug, we set it to body. So we want to see everything in the response. So as we're communicating, we can see all these responses inside of logcat, which we'll see inside of here. So all different types of messages will be sent, and we can see right here, there was a post. This is the information that comes with OkHttp, the logging interceptor. We see all the information from the request, the responses, etc. Now inside of here, we also need the user agent. The user agent, we provide an interceptor. An interceptor allows us to intercept the request and responses of a request and do certain things with them. And we have multiple different versions. Here, this one, we are just setting up the header of the user agent. And we say Hotwire Native Android, and we provide a default user agent, which is from the HTTP agent from the actual system itself. So here, when this goes up to the server, we'll see that we have the user agent of Hotwire Native Android. And then when the server gets there, it can detect by inspecting the user agent who's communicating with it. In this case, it can then decide to do certain things on the API, saying, oh, in this case, since it's coming from a Hotwire native app, we need to maybe inspect something else. From there, we also have the cookie interceptor. This is very important because all of the cookies are managed in the web views in Android, such as we see here. This is a native web view inside of Android. All of the cookies are stored in what's known as a cookie manager, and that's handled for us out of the box. So as long as we're authenticating in the web and we're getting cookies set back and forth from the web context, those are stored in a local cookie manager, which is what we're getting here. Then if we want to communicate with the backend, since we're using cookie authentication, we need to grab that cookie from the cookie manager, which is what we're doing here. And then we need to add that cookie to the actual headers of the request. So we actually add the cookie to the request headers, and then we can send the request off to do its job. Once it hits the server will then can inspect the cookies like it normally would and say, oh, I can authenticate this user. I've got the authentication session cookie, etc. And then that will just work on the server side with Jumpstart Pro. Now we also have the ability to inspect the responses, which is what we're doing here. So we've proceeded with the chain of events. These are the things that are happening. And then we're gonna say, hey, let's check to see if we have anything in the response. If we have a set cookie header in the response, well, that means we can set the cookies inside of the request interceptor here for the cookies and set an updated cookie value if we have it. So everything happens for cookies in this one. We have a accept JSON interceptor, which basically just tells the server, hey, we can accept application JSON. And then we add the interceptor logging, which we've already configured above, and we build that. So this OkHttp client is provided to Retrofit here, and then it's built in here as the client, which powers Retrofit. So we get all these things built in for free. So if the cookies are updated in the web view, we're going to get the updated ones in the interceptor here. If the interceptor finds updated cookies and HTTP responses that we have from the API, it'll update those back in the cookie manager, which the web view will automatically read. So everything is kept in sync. And this is how we can communicate back and forth with the actual endpoint of the server, which is going to be the API server. If you need to add your own different types of API endpoints, you would go to API service, and then you would provide what type of request is it. It's going to be a post, a put, a delete, a get, the name of the route. So if it's going to be, say it was message, you would say you want to get all our messages. You want to get all the messages. You say get messages. Provide this as a suspend function, which is a Kotlin coroutine asynchronous function. And then we could then provide the response. This is the return type. Here we have unit. Unit is basically void, which means it's nothing. It doesn't do anything. It's not returning anything. And then we have the error response. The error response is what the response from the server is. This is what comes back from Jumpstart Pro. And here's some example of what an error response could look like. And we parse that into the proper error response so we can investigate it if there is an error from the server itself. So if you do have a response that comes back and it's going to be a response that contains multiple messages, well, then you're going to need to create a plain old Kotlin object, usually a data class that has that same structure that you need to implement. And you'd add another one here. So it'd be, you'd say something like get, and then you would have messages, and he would need to import this, and then you can say suspend, and then say get messages, and this would have this, but now you perhaps have to say, user messages object. And this doesn't exist, of course. This would be the Kotlin object you would create. And then you could call get messages. It would then send a get request up to the messages API endpoint and then return back all the messages if it was successful. Otherwise, the corresponding error. That's how you communicate with the API and the network infrastructure inside of Jumpstart Pro Android.